Welcome to Programming Fluency. This is section 6.2, Pointer Arithmetic. You already know that a pointer holds an address, which is just a number. So a fair question is, what happens when you do math on that number? In this video, you will find out, and the answer is the key to how C walks through arrays at full speed. A pointer holds an address, which is just a number. So a fair question is, what does it mean to add one to a pointer? Let's find out. The answer is the key to how C walks through arrays at full speed. This is the plan for this video. We start with the core question. A pointer holds an address, which is just a number, so what does it actually mean to add one to it? You will see what p plus 1 really does. Next, the scaling rule. Adding 1 to a pointer moves it forward by the size of one element, not by a single byte. We also look at the special case of a character pointer, where one element is exactly 1 byte. Then we cover increment and difference. The plus plus operator walks a pointer forward one element at a time, and subtracting two pointers tells you how many elements lie between them. After that, we walk through an array using only pointers. You will learn the safe pattern for looping, including the rule that lets you point one position past the end of the array. Finally, we connect the two notations. Indexing with square brackets is really just pointer math underneath, and we look at a classic mistake where the byte counting goes wrong. Let's start with the puzzle. A pointer holds an address, which is a number. So if p holds the address 1000, does p plus 1 give you 1001? The answer is no. Adding 1 to an int pointer does not move ahead by 1 byte. It moves ahead by the size of an int, which is typically 4 bytes. So p plus 1 gives you 1004, not 1001. This is the rule that makes it all work. The compiler scales every pointer addition by the size of the type it points to. So adding an integer n to a pointer p gives you an address that is n times the size of one element forward. The scaling happens automatically. That means p plus 1 always points to the next element, never just the next byte. Add 1 to a double pointer and you move 8 bytes. Add 1 to a char pointer and you move exactly 1 byte. Let's see it in code. We make an array of 5 ints 10 through 50, then p points at the first element. When we print star p, we read 10. When we print star of p plus 1, we read 20, and star of p plus 2 reads 30. The expression star of p plus n reads the element n positions after where p points, which is the same as r at index n. This is the array in memory, 5 ints with values 10 through 50. Each element sits at its own address, starting at 1000. The pointer p points to the first element, at address 1000. Now add 1. P plus 1 points to the next element, at address 1004. Look at the jump. P plus 1 moved 4 bytes forward, not 1 byte. 4 bytes is the size of one int. The compiler scales the step by the type size, so pointer arithmetic counts in elements, not bytes. Why does C work this way? Convenience and safety. Without scaling, you would have to multiply by the size of the type yourself every single time you moved a pointer. That p plus 1 times sizeof int on the slide is just pseudocode to show the wish, not real C with scaling. You just write p plus 1 and the compiler does the right thing. This also makes your code portable. The same source code works correctly whether an int is 2 bytes, 4 bytes, or any other size, because you never hardcode the size yourself. There is one special case worth knowing. The size of a char is always 1, by definition. So adding 1 to a char pointer moves ahead by exactly 1 byte. That makes char pointers the natural tool when you really do want to walk through memory 1 byte at a time. Here we take an int array, view it as raw bytes with a char pointer, and step 1 byte forward. This is the exception that proves the rule. You do not have to write p equals p plus 1. You can use the increment operator p++ and the same scaling applies. Watch what happens. We start with p pointing at the first element and star p reads 10. Then p++ advances the pointer to the next int, so star p now reads 20. One more p++ and star p reads 30. Each p++ steps forward by one whole int, which is 4 bytes. Also see how we wrote int star p equals r without the ampersand. An array name in an expression becomes a pointer to its first element. More on that next section. Here we see the output, 10, 20, 30. The same scaling works in every direction. P moves back one element. P plus equals 3 jumps forward 3 elements at once. P minus equals 2 moves back 2. And no matter where the pointer sits, star P always reads the element it currently points to. The pointer is like a moving cursor. Pointer math also works the other way. When you subtract one pointer from another, you do not get a byte count. You get the number of elements between them. Here P points at index 1 and Q points at index 4. When we print Q minus P, we get 3. Even though Q is 12 bytes ahead in memory, the subtraction divides by the size of an int and gives us 3 elements. We print it with %td, the format for a pointer difference. Let's write down the definition. Subtracting 2 pointers into the same array gives the number of elements between them, and its type is called ptrdiff_t if p points at index I and q points at index j. Then q minus p equals j minus I. The table sums up all 3 forms. Pointer plus integer gives you a pointer, scaled up by the element size. Pointer minus integer also gives you a pointer, scaled up by the element size. Pointer minus pointer gives you an integer, scaled back down by the element size. One warning: only subtract pointers that point into the same array. Now we can put it all together. Instead of an integer index, we can use a pointer that walks through the array. Look at the for loop. It starts with p at the first element. It continues while p is less than r plus 5, and it does p plus plus each time. Inside, star p reads the current element. The output is 10, 20, 30, 40, 50. This is the classic pointer traversal pattern, and you will see it everywhere in C. This is the array we will walk. 5 values 10 through 50, plus one extra slot on the right, one past the end. The pointer P starts at index 0, address 1000. Star P reads 10. P++ moves P one element forward. Now P is at index 1, address 1004. Star P reads 20. P++ again. Now P is at index 2, address 1008. Star P reads 30. P++ again. Now P is at index 3, address 1012. Star P reads 40. P++ again. Now P is at index 4, the last real element, address 1016. Star P reads 50. One more P++. Now P equals R plus 5, one past the end. The loop test, P less than R plus 5, is now false, so the loop stops. You must never read this slot. Look again at that 6th column, marked Do Not Dereference. The expression R plus 5 points to the address right after the last element. C lets you compute this address and compare against it, which is exactly how the loop knows when to stop. But you must never dereference it. Star of R plus 5 reads memory that does not belong to the array, just like R at index 5 would. If you want the last element, use star of R plus 4 or star of end minus 1. This is a fact that surprises many beginners. The bracket notation R at index I and the pointer notation star of R plus I are exactly the same thing. The compiler literally defines one in terms of the other. Behind the scenes, when you write R at index I, the compiler computes the address R plus I with scaling and dereferences it. The output confirms it. Every line shows the same value on both sides. Use brackets for simple access, and pointers when you are walking a range bounded by 2 pointers. Let's clear up the most common misconception. A beginner writes star of p plus 1 and expects to see the next byte, some piece inside the number stored at p, but that is not what happens. Because p is an int pointer, p plus 1 advances by the size of an int, 4 bytes, and points to the next whole int. This is not really a bug. The code works. The mistake is in your mental model. Remember, pointer arithmetic counts elements, not bytes. If you truly need to move 1 byte, cast to a char pointer first. Let's recap. Pointer arithmetic is scaled by the size of the type it points to. Adding n to a pointer moves ahead by n times the element size in bytes, so p plus 1 is always the next element. Subtracting 2 pointers gives the number of elements between them, not the bytes. To walk an array, use a for loop that starts a pointer at r, continues while p is less than r plus n, and does p plus plus. You may compute r plus n for comparison, but never dereference it. And r at index I is identical to star of r plus I next. You have seen int star p equals r work without an ampersand. In section 6.3, Pointers and Arrays, you will learn why an array name decays into a pointer to its first element.